Okay, welcome back to the channel. In this video, we are going to solve and deeply explain a set of numerical and conceptual questions from statistics, machine learning, probability distribution, and deep learning basics. These questions are extremely common in exams, and understanding the logic behind each one will help you score full marks. So let's get started with the first one. That is probability. Compute probability. A fair die is rolled twice. The probability that sum is 7. So the formula of probability is number of favorable outcomes divided by total outcomes. So when we make the sample space for die, it gives us 36 items in that set, and out of this, 6 will be our favorable, which makes the total sum of 7. So those 7 favorable outcomes will be 1 by 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1 out of these 36. So those total are 6 divided by 36, or 1 by 6, so answer is 0.166. 0.166. Let me just remove this. Moving on to the next question. For a binomial distribution n equal to 10 and p equal to 5x expected value. So its formula for mean in binomial distribution is n into p. So we are given with the values of n and p both. N is 10 and p is 0.5. 10 into 0.5 gave us 5. So average is 5. You expect 5 successes in 10 trials. Now let's move on to the next question. If r square equal to 0.8 and TSS equal to 100, compute RSS. So RSS will be, we have to first understand the relationship. R square equal to 1 minus RSS divided by TSS. So to calculate the RSS, we will first rearrange this into TSS into 1 minus R square equal to R. I have done nothing, just arrange this equation to this, and now we'll put the values as 100 into 1 minus 0.8, that is 100 into 0.2, and we'll get the answer as 20. So its answer is 20. Let me remove this and we'll move on to the next question. So the next question is, in linear regression, the gradient descent update rule for weight equal to w minus alpha x. So filling the blank will be w nu equal to w minus alpha into delta loss by delta w. In gradient descent, we update the weights by moving them up in the opposite direction of gradient descent, because that direction reduces the loss. In this, alpha represents the learning rate, and this is the gradient current weight, and this is the new weight. So it says answer will be dl by dw. So the next question, let me first remove this. Hold on. So the next question, for a normal 0, 1 distribution, what percentage of data lies between -2 and +2? So its answer will be 95%. 95%. Because for standard normal distribution, mean is 0 and standard deviation is 1. We use the 68, 95, and 99.7 rule, in which the first standard deviation covers 68% of data. 68% of data. Second standard deviation covers 95% of data, and third standard deviation covers 99.7% of data. So our answer will be 95%. So moving on to the next question. In 5-fold cross validation, what percent is used for training? Okay, so its answer will be 80%, because in k-fold cross validation, data is split into k parts. Where in each iteration we use k minus 1 folds for the training data and 1 for the test data. So k minus 1 will be used for training. So here we have the value of k as 5 minus 1 equal to 4, and 1 value will be used for testing. So our answer will be 1 by 5 equal to 20% for test, and 4 by 5 equal to 20% for 80% for training. So let me first remove that, and then we'll go on to the next question. So in this question, we have to compute the precision. We have given the value of true positive, that is 40, false positive, that is 10, and we have to find the precision. So the formula for precision is equal to true positive divided by true positive plus false positive. Precision tells us how many predicted values were actually correct. So we are given with the true positives. So the answer will be 40 divided by 40 plus 10. 40 by 50 equal to 0.8. So our precision will be 0.8. So the model is 80% precise. So next, moving on to the next, if recall equal to 0.8 and precision equal to 0.4, we have to find the F1 score. So its formula is F1 score is a harmonic mean of precision and recall, so which stands for 2 times the precision into recall divided by precision plus recall. So we are given with the values of true positive, false negative. So we'll calculate the No, we are given with the values of recall and precision, that are 0.8 and 0.4. So 2 into 0.8 into 0.4 divided by 0.4 plus 0.8. So answer will be 0.533. 0.533. So let me just remove all of this and we'll move on to the next question. So next question gives us a model that gives true positive equal to 70, true negative equal to 80, false positive 20, false negative equal to 30. So we have to find the accuracy. So the formula for accuracy is true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. So we are given with all the values. 70 plus 80 divided by 70 plus 80 plus 20 plus 30. We'll get 150 by 200, which roughly translates to 0.75. So our accuracy is 0.75, it is 75%. For a Poisson value of lambda equal to 3 distribution, we have to find the expected value. So answer will be 3. Because in a Poisson distribution, expected value mean equal to lambda. So lambda equal to 3, so the mean equal to 3. So now we are done with all the filling the blanks. So thank you for watching and I hope you get all of this.